Alright guys, it's time for the next video, and it's time for the not so fun but definitely important part of calculating the distances that we're going to need, the lengths of the different lengths of the compensation, of the length that we'll need from the 12th fret to the saddle to get the correct angle, basically, so the intonation will be on. Now, I start off by saying pretty much most nylons that I've seen, or all of them, I'm assuming all of them are this way. They're 12 fret guitars, and by that I mean the 12th fret here, right here, meets the, that's where the heel block, the end block here of the neck meets the body at the 12th fret. And a lot of, or pretty much I think most parlor guitars, steel string parlor guitars are also designed that way, a little shorter scale length. And I happen to have a shorter scale length, the parlor guitar, steel string guitar that's a shorter scale length like that. The 12th fret meets the body, or the 12th fret, the end block meets the body at the 12th fret, instead of the 14th fret, which I think is where a lot of the more modern steel strings meet the body, like the Martins and the Taylors that come out in extra 2 frets that give you a little longer scale length. So ideally, I do think it would be better if you could get a steel string guitar, get your hands on one, you know, maybe your friends got one, or whatever, even just maybe go to a store and do some quick measurements, because the scale length is going to be a lot closer, you know, on a 12 fret steel string than on a 14 fret. But having said that, I actually have done this in the past. The first time I did this, I think I mentioned earlier in another video, I did this with another guitar. I actually used a 14 fret steel string, and I calculated the compensation distance off of that, using that as the, I'll show you here in a sec how I did it, but using the 14 fret scale length rather than a 12 fret steel string, and actually it worked just fine. The intonation was right on. So you probably could get away with it, but I think if you can get your hands on a 12 fret steel string, you'd probably be better off. Alright, so here's basically what I did. I'm going to try to explain it the best I can. I'm definitely not a mathematics expert, but you know, this is kind of a simple equation, so hopefully you guys can follow my sloppy work here. So what we got, the SS here stands for, I don't know how well you can see as I'm kind of trying to look at both, look at the paper and look at the screen, so I don't know what you guys see. The SS stands for steel string, and the NS stands for nylon string, right? Okay, so that's easy. Down here you see the N to 12 is nut to 12th, and 12 to S is the 12th fret to the saddle. So the nut to the 12th fret to saddle, try to keep it simple. LE is low E, HE is high E, so the low E string, the high E string. So basically we got, I guess it's what, 8 calculations, or 8 measurements I should say, 8 measurements for both guitars, so 4 measurements per guitar, right? So I started off with the steel string. So now that's going to be my model, right? That's what I'm going to try to calculate the distance that I need here from the 12th fret to the saddle for my compensation, to find out what, you know, what angle compensation I need. I'm going to use the measurements that I got from my 12th fret, because that is a steel string guitar and it has the correct compensation. And the scale lengths happen to be very similar after I did the measurements. So again, because it's a 12th fret, not a 14. So from the low E string on my, again, we're on the steel string here. So starting with the low E string, from the nut to the 12th fret, I got about, what is that, 12 and 10/16 of an inch. And then when I measured from the 12th fret to the saddle, again, we're talking about the steel string, I got about 12 and 12/16 of an inch, okay? And then of course I measured the, and you expect these two measurements to be the same, of course, because you're measuring from your nut to your 12th fret. So these 4 measurements here on top should be the same, because if they're not, that means your 12th fret here is like crooked, right? And that wouldn't be good. So we're assuming, I mean, I did measure them and they came out to the same, but you know, you can measure them just for the heck of it, but they should be the same. So again, measuring from, you know, the nut to 12, same thing, no surprise, 12 and 10/16. Now this is the important one, because this is what's going to give me my compensation, right? So measuring from the, and I'm measuring from, again, the 12th fret to the saddle on the high E string. Surprisingly enough, it's kind of surprised me. I expected it to be a little less because it's at that angle, but it turned out to be identical. I measured a couple times, it was identical. It was 12 and 10/16 of an inch. So I got 12 and 10/16 of an inch from the nut to the 12th fret, and from the 12th fret to the saddle on the high E string end, just on the high E string end. There was no difference. On the low E string there was, on the high string there wasn't. So I'm going to stick with that. And I'm going to, now again, if a luthier sees this, they're probably going to say, hey, that's not correct. It should be a little bit of a compensation there too, and I'm sure they're right. But on my guitar, that wasn't. Now, of course, there's something called B compensation, I believe, like the B string gets compensated on the saddle. You might have seen that. Maybe if I have time, I'll try to talk about that later. I don't really know much about it, besides I can maybe show some examples of different saddles that have that, and maybe that's compensating for this not being angle. I don't know. But anyway. So basically what we're trying to figure out though, so what we do is we got one number that's different. That's basically just the 12th fret to the saddle on my steel string was a different length than the nut to the 12th fret on the low E string. So that is where my compensation is going to come in. That's going to move this down a little bit. The saddle is going to be moved down towards the butt of the guitar here. It's going to angle it like that. So that's important. We need to know that number. So how are we going to figure out that number? Well, a little bit of math. Same thing if you can follow it here, just on the other page. What I did, make it real simple. You got the low E string, again, SS steel string, NS nylon string, then the nut to the 12th, and then 12th to the saddle. So basically what I did was I just put the values in that I have, 12.625. Well, again, I'm sorry, I converted it to from inches to fractions, and then when I was done, I converted back to fractions again. So I divided 10 by 16, 12 by 16. That's how I got my numbers, and then 10 by 16 again. Okay, same thing, right? Okay. So again, so now I'm dealing with fractions because I think it's easier to deal with fractions at this point when you're multiplying, dividing. I'm sorry, it's easier to deal with decimals at this point, and then when you're done, you can convert it back to a fraction. So that's what I did. So basically, these numbers are the same. So this is the same as this, and this is the same as that. It's just one. This is in fraction, and this is in decimal form. Okay, so what I did was, again, from the nut to the 12th fret, I got about 12.625 inches, and from the and again on the steel string, and then from the 12th from the 12th fret to the saddle. Remember, that's where I got my compensation. It's a little bit longer because remember it's compensated down. I got 12.75 inches. That's after converting these decimals. I don't know why I keep saying. That's after converting these fractions into these decimals. Okay, now over on the nylon string. Now remember, on the nylon string, we're only going to have one number here. You should only have what your distance is from your nut to the 12th fret, because obviously we're trying to or I guess I should say here on the low E string, trying to calculate this other distance. We don't know what this distance is yet. We don't know what it should be. That's what we're trying to find out. So you're just going to have one number here, and that's going to be this, what it is from your nut to your 12th fret. And I came up with a 12 and 23/32, which after doing the math, again dividing 23 by 32, came up with 12, what is that, 12.71875, I guess. So anyway, so now I have these two numbers. So I have the nut to the 12th fret on my steel string. The distance is 12.625, and the 12th fret to the saddle is 12.75. Okay, so that's because that's a known distance, because my steel string is obviously already set up, it's already compensated, so I know that that's the correct distance. So I can calculate what the distance should be on my nylon string simply by cross multiplying and dividing, right? So I have this distance, which I know, nut to the 12th fret. I have this distance, which I know, 12th fret to the saddle. And I have this distance, which is known, which again is my nut to my 12th fret on my nylon string. So all I need to know is what should be that distance between my 12th fret to the saddle on my nylon, so I can compensate. So I'm just going to cross multiply and divide. So doing that, I simply just took 12.71875 times 12.75 divided by 12.625, and this is what I came up with, that big number there. Here's where I cheated a little bit. I guess there should be a 12 here. And I just simply, I don't know, I'm not, like I said, a mathematician, so I don't want to try to convert fraction and decimals in my head or on paper. So I went to Google and I found a decimal to fraction conversion calculator, and I just went ahead and calculated this, and I double checked, and it seems to be right. So this long number, this long decimal, comes out to about 27 seconds of an inch. And again, of course, we're dealing with 12. That's our root number. So 12. So 27 of an inch is the difference in compensation between our low E string. So as you can see, it's not a whole lot, because what I measured from the nut to the 12th fret is just 23/32, and what I came up with from the 12th fret to the saddle is 27. So what? It's about 4/32 of an inch, which is what, 2/16. So it's not a lot, but it's enough. I mean, it's going to make a difference in your intonation. Believe me, when you're trying to tune your guitar, you need that difference. You need that angle, or else the intonation is not going to be right on. And again, I'm trusting that my steel string, because I played, it's a great guitar, the intonation is right on. I'm trusting that it's correct, and I'm going to go ahead and leave. I put this over here just so you can kind of see it, but I didn't even finish doing the calculations, just so you can see that you could theoretically do the same thing with your high E string, but I'm not going to, because remember, on my steel string, I measured the same distance from the nut to the 12th fret. So on my steel string, it was the same distance from the nut to the 12th fret was the same. The 12th fret was the same distance as the 12th fret to the saddle. So basically, there was no compensation going on. They kept that exactly the same. So I'm just trusting that. I'm going to stick with that. I'm going to leave that the same. So that'll be the same. That'll still be 12 and 23, 30 seconds, which is what I measured it here. It's going to be the exact same difference. It's only the low E string that's going to drop down. What was it? I think it was 4/30 seconds, 2/16 of an inch, something like that. So that's going to drop down. So I know that's I probably explained it the best way. Again, I'm not a mathematician here or anything, or a physicist. It's just what I've done before. I mean, I have some basic college level algebra and stuff, and I don't know. It's kind of dealing with proportions and whatnot, and it does actually work. And I'm gonna finish this too. I'm gonna actually do this on this guitar, and I'm gonna place the saddle and string it up and everything, and play it for you guys later. So we'll see how it turns out. Having said that, there is some websites online I know that they do these conversions for you. They have, for instance, scale length and saddle compensation calculators where you could measure, like say this distance from your nut to your 12th fret, and you could put that in, and it will tell you automatically. It'll say, well, this should be it'll say from the 12th fret to your saddle should be this long on the low E string side, and your 12th fret to your saddle should be this long on your high E string side. And you can, and I'm assuming those are accurate. I never used them. I think Stu Mac might have one. Stuart McDonald's. Maybe some other websites or guitar building luthier places might actually have them, and they probably are very accurate. In fact, they're probably more accurate than what I'm doing here, but I just know that I've done this in the past and it's worked, and I'm going to kind of stick with what I know. So the next step is going to be simply to measure that distance. Well, I guess from here, from this 12th fret, measure this distance to that saddle, make a little mark, and then measure that distance again. I'm assuming it's going to be right in the middle there. It should be, but again, this isn't the highest end guitar, right in the middle where the saddle sits. But since it isn't the highest end guitar, this intonation might not be right on either, so I might be on the other side of that. Even though the distance is the same, I don't know what they did here with this intonation. So that's going to be my next video. All right, guys, we'll see you then. Bye.